Yeah, something like that. So as we heard in the keynote, HPC deals with thousands and thousands of nodes, and being able to manage those nodes can sometimes be a challenge. We heard from Christoph and others that looking at the nodes on an individual basis, I hit space, okay, and I've had a lot of conversations over the week about this. In an HPC system, sysadmins don't consider the node, the Linux kernel, really the server. It's just a device hanging off of this fabric. It's one small component of what is considered the larger machine. Linux and the maintainers, they do a great job of building a very stable kernel that can be used in a lot of devices, phones, servers, data centers, HPC. But we have some unique challenges when managing a cluster that has individual nodes that were designed to be configured individually, but we want to configure them and run them as if they're a single machine. These nodes can almost be considered like a PCI device. And so as we look at the configurations, we're investigating how to make this easier for sysadmins to configure, more automatic when software's run on these nodes. And I'm going to present two specific daemons that we've created to help with that and discuss a little bit of future work. So the first one is Ibacm. As all of you know, Sean wrote Ibacm many, many years ago. And it started out by caching PathRecord data as nodes were querying for that data on a fabric. Path records, as we all know, an InfiniBand and an OmniPath are very important to make sure you understand your path information. Quick slide from the man page provides a framework for name, address, and route resolution over InfiniBand and OmniPath architecture. We could update the man page perhaps. And we have, it's built up with three components. There's a core daemon called Ibacm, started by systemd. There's a test configuration tool called Acme. Sean is famous for his unique and creative names. And then there is the library, librdma-cm, which we're all familiar with, which ties into this and allows for verbs applications and anyone else wanting to create a queue pair to query this data. In the past, so in order to truly run an InfiniBand fabric or an OmniPath fabric that has especially advanced topologies, you must understand your path information. For those of you who have run toruses or the hypercubes, getting that right SL information is critical. But Ibacm has, in the past, been considered not scalable. It doesn't scale. It does some multicasting in its default provider. It does some things that have been not scalable. But we've made some enhancement to Ibacm and have provided a plugin for OPA. And I know Mellanox had a plugin for InfiniBand. I'm not sure what the status of that is. So local SA daemon, and I presented the proposal to kind of do this work a couple of years ago, and I used this same diagram. It's been modified slightly to update for some real plugins. The core Ibacm provides a default plugin. It provides very much the same functionality as it always has. There's been some enhancements to that. Then there's an IBSSA plugin, and as I said, I'm not sure where that stands. I looked at the GitHub for it, and it looks like it hasn't been updated for a couple of years. And then we have provided for OmniPath networks a plugin called DSAP, Distributed SA Provider, or plugin. So that work is complete. We've added the plugin architecture to Ibacm, and the plugins are now available. Also, to support the kernel side of things, we now have kernel support. So for path records that ULPs are querying for, they query into the IBverbs core, into the SA client code. Those issue a send mad. And if the local service is enabled, Ibacm, it will call into Ibacm and check there for a path record query. It's very similar to the ARP cache daemon that exists for ARP caches. And if Ibacm has the path record, it returns it. If it doesn't, it fails, and it goes ahead and falls back to the SA so that your kernel will continue to function even if Ibacm isn't running or if Ibacm has crashed or whatever. So it's robust. Don't worry, kernel's not going to stop functioning. And I'll discuss some ideas to enhance that, because some people may be wondering, well, if the kernel ends up falling back to the SA, doesn't that also hurt your scalability? Yes, maybe it can. Currently, only IB path records are supported through the netlink interface. We are looking at extending that to OPA path records. As Todd presented earlier, OPA has an extended lid address. It has other extensions like the number of SLs, and so there's a new path record format that the kernel is going to be enhanced to understand, and then we'll need to enhance that for Ibacm. Multicast records as well. We want to be able to query for multicast records and multicast groups so that we can cut down on that traffic to the SA, cut down on that single bottleneck. So I'm going to kind of go into a little bit of a tutorial on how do you use Ibacm, because I think that on many of the clusters, people have kind of turned it off, disabled it, maybe don't even install it. We'd like to encourage people to use it because it's a path to getting scalability into your clusters and proper functioning by getting proper path records. Many people in their MPIs, they hard code things, SL, MTU. As we go forward with more advanced topologies, bigger fabrics, these things aren't going to work as effectively, or they're not going to work as automatic. And it'll be really nice to have these functions built in. So how do you get Ibacm? Well, your friendly neighborhood distro has Ibacm built in, rel/Ubuntu. If you're looking for the latest and greatest, the rdma-core now includes this as part of the daemon. I believe Jason listed it when he presented rdma-core. The version that supports plugins is version 1.1.0 or greater, but as Jason mentioned, the rdma-core is shifted over, so the initial release of rdma-core 12 included the plugin support that you need. So the plugins have been there to start. As we ramp up the other SA attributes through netlink, obviously new versions will be needed for that. The kernel support for netlink was added in 4.3. The plugins, I mentioned this a little bit. ICMP is the default plugin. It's provided and included in the rdma-core package. IBSSA was an external provider for OpenSM. And I mentioned the DSAP plugin. DSAP can be obtained by our GitHub page, which is part of the OPA FF. FF stands for Fast Fabric. The RPM name that comes out of that package is called OPA Address Resolution. So that RPM is a separate plugin that can be installed if you're running on OPA fabrics. So this gets into a little bit more detail on how the DSAP plugin works, which is what I'm going to go over here. For those of you who don't know, I work for Intel, and so OmniPath is my focus. So the other thing that we've heard from users is that sometimes going through rdma-cm can be a bottleneck when querying through Ibacm. And that bottleneck is because of the socket interface that's created between rdma-cm and Ibacm daemon itself. So with DSAP, we've extended this a little bit to include a shared library access that can be accessed directly from libfabric or PSM. And so we've worked with Sean a little bit, and we kind of expect that other providers could also provide this as well, but I don't know what their status is. So in order to configure IBACM, IP over IB is basically required. Most people that use rdma-cm understand that rdma-cm by default does address resolution from host name to an IP address on an IB0 IP address. That gets turned into a GID. That GID gets turned into a lid or can be used to query the path record directly. So currently, IP over IB is a requirement for IBACM. For those of you who know the details, librdma-cm can do an AFIB query, but for the purpose of this demonstration and how most people will use IBACM and librdma-cm, you're going to want IP over IB to be running. So I've kind of glossed over how to configure that. I assume most people know how to do that. So configure your providers. As I said, I'm going to go through the DSAP provider for Omnipath as an example. Edit your IBACM ops config file. This is where the defaults are provided. And can I go back? As I showed in this picture, each port can potentially be connected to a different subnet. Even ports that are on the same device can be connected to different subnets. So this is very important. Yes, most HPC clusters run with a single port, maybe dual rail, 2 ports, same subnet, but we're getting more and more clusters with multi-plane, where there's 2 ports connected into 2 fabrics that are identical. We have lots and lots of clusters that also have I/O routers. Lester talked about routing from InfiniBand to InfiniBand, or InfiniBand to Ethernet, or Omnipath to InfiniBand. So when you have these router nodes, you're going to have multiple ports. So when we get into the configuration of your plugin, the configuration here needs to specify the subnet prefix. So that tells the plugin which subnet it's looking. And now the plugin will know if 2 ports are plugged into the same fabric. It will, through the subnet prefix, recognize those are the same fabric and be able to cache that same database and optimize that. If this file doesn't exist in your system, Acme can be used to generate that config file for you. Ensure that IBACM is enabled. I'm assuming everybody understands systemd, so tell it to be enabled on start and restart IBACM. Obviously, if you're in a cluster, you need to be able to configure this for all your nodes, however you do that. And once you do that, Acme can be used to go ahead and test a query. In this case, I'm just querying for a source lid of 2 and a destination lid of 1, and I get a path record back. Very simple. So key points is, with verbs traffic, we really need to use librdma-cm to make this work. And this is not only for this configuration, but as we've heard about Rocky, we've heard about our iWarp, there's InfiniBand, and Omnipath. So now we have 4 different networking topology, or networking types. And using librdma-cm is a nice abstraction that can make sure that your address resolution occurs properly on all of those network types. So for a long time, and I don't know that anybody is really using the old IB connection manager protocol. So I'm assuming everybody's using librdma-cm, but if you're not, start. IBACM is automatically contacted under this condition, and the cache path records are utilized. So if you're doing rdma-cm already, once you've configured IBACM, you're good to go. So I'm going to give an example of how to use PSM2. I mentioned that there's this other higher speed path that we have in the shared memory database for PSM2. So with PSM, the library, there's an environment variable to export, and you can do this in your MPI run scripts or set it to your environment variable. And once you do this, or if you don't do this, here's the error you will get if you have turn on this environment variable and run PSM without DSAP running. So I just throw that in the slides as an example for people to reference later. And if you, I apologize. I should have had a slide in here showing a run of some MPI job. Anyway, once you configure it and run it, you'll see an MPI job run. Now, if you're on a small test cluster, you're probably going to notice no difference, because querying the SA directly on a small test cluster, up to a few hundreds, even 1,000 nodes, probably you're not going to see any difference. But if you're running on 5,000 nodes, or a couple thousand nodes, or you're launching lots of small jobs on a large cluster, that's where you're going to start to see the difference. So that's where that performance kicks in. For reference, the log files for Ibacm are var log Ibacm, and the 2 config files are listed here. So further work. As I mentioned earlier, we want to be able to support OPA path records as well through the netlink interface. And we want to support multicast records through the netlink interface and multicast group records. And I've discussed this with a couple people. We'd like to be able to get Ibacm to run before the kernel ULPs, because I don't want IP over IB in particular, it's common use, to need path record information before Ibacm is ready to provide that cache. And so Jason came up with an interesting point of view. I guess the Ethernet network basically disables a port until user space has configured what it needs to do and then enables the port. So we're going to investigate that. We've also investigated changing systemd startup scripts to ensure Ibacm runs before the kernel ULPs. And so that's work that we'll be talking about with the community, possibly on the mailing list, as we may need to change things in the rdma-core. And again, that's to make sure that things are really up and running and configured before we need that service for the kernel. So again, I mentioned multicast group join leave operations. IP over IB is dependent on that. One of the things that we've investigated is ensuring that groups are pre-joined. So when a node comes up, it doesn't have to join a group. We could create a group, we could have a node pre-join, and we could tell Ibacm that node is pre-joined. We could even pre-configure Ibacm to know that. And then when IP over IB comes up, it says, I want to join this group. Instead of that going to the SA, it goes to Ibacm. Ibacm says, yeah, I know that you're configured to be in this group, and returns that information, again, without any SA information going over the wire. Multicast records, similar. And pre-configured topologies. And this allows us to have topologies that are homogeneous and pre-configure Ibacm with a cache, if you will, of path records. It would be like using the ARP cache daemon and preceding that ARP cache with a bunch of ARP entries. So that's the idea here, is precede Ibacm. And again, this gets back to being able to get Ibacm up and running before the kernel's up and running. So now those path records are available almost before the node boots, and they're right there. And we need to look at removing the IP over IB dependency. There are ways to get around this, but it's not really as automatic as it really ought to be at this point. So the other daemon I'd like to discuss is rdma-ndd. Jason kind of called it out in the rdma-core work that he's done. I added this to the InfiniBand diags originally, roughly a year ago. And setting node descriptions has a long history. I personally wrote a script 10 years ago to attempt to do this on our clusters at Lawrence Livermore. I believe that rdma-ndd has finally done what we really want to happen, which is set your node description to your host name automatically, reliably, without race conditions, every single time, if your host name changes, when a device comes up, forever. So yes, and about the RHEL 6 timeframe, there was UDEV rules written to try to do this. The TrueScale IFS hard-coded this in the driver. And oh, I guess it was 2014, so geez. 3 years ago, I wrote rdma-ndd, and I threw it in InfiniBand diags. Unfortunately, I don't think it's really caught on, so I really wanted to get this out to this community especially. As I said, it watches for host name changes, automatically updates these things, watches for device adds, responds to these device events. It's configurable to either use the host name or not, to use the device name or not. I haven't thought of any other flags to add to the configuration, but if anybody has any ideas, I'm open to suggestions. So where do you get it? Friendly neighborhood distro. RHEL 7.3 at least already includes this because it was part of InfiniBand diags. Now, due to some issues with the packaging and other things, they split this out into its own RPM. And with rdma-core, it is also split out into its own RPM, which is kind of nice. So it was added to the InfiniBand diags version 1.6.5. I am going to deprecate that out as it's now in the rdma-core, and most of the distros should be picking it up from there. And unfortunately, when I added it to the rdma-core, Jason had a lot of suggestions on how to configure it. Originally, it used the ibdiag config file to be able to configure it, which was convenient because it was part of that package. Obviously, when I moved it to rdma-core, I couldn't use that same config file. And instead of having a config file, Jason suggested that we just use systemd directly. Systemd has configuration options built into it. And indeed, those worked out to be easier to use. So depending on where you're getting it from, the configuration is a little bit different. Check the man page. The man page is correct depending on which version you got. So if you read the man page, you'll figure out how to configure it appropriately. But basically, %h replaces it with a host name. %d is the device name. The default is host name space device name. So, you know, an MLX4 card comes up, and it'll be called, you know, Ira's Great Node space MLX4_0, if that's the only card. So I'm going to get us to lunch early. Sweet. In conclusion, there's 2 new daemons that should allow sysadmins to configure and manage their clusters in a more automatic way, in a scalable way. Those daemons are Ibacm and rdma-ndd. And you know, we've done a lot of little work here. We have some future plans. If people have ideas, I'm welcome to patches. Any questions?
So on the naming, any ideas how to extend that to switches? Because we have those that change too, and so I've got a way that I deal with that. But you know, naming is for all the elements, not just the nodes.
Understood. In Omnipath and QLogic switches, you've always been able to write a name to the switch itself, and it's stored in the firmware. In InfiniBand, unless something's changed, I wrote the switch to GUID map file name. So that's part of OpenSM. I believe it's still part of OpenSM, and that can be configured. Now, if you swap a switch out, that file would have to be updated. In Omnipath, at least we have a set of tools that as you're bringing your cluster up, you can say, I want these switches to be named this way. If you swap a switch out, you'll have to go in and individually rename that, but there's tools that go ahead and we have a vendor-specific MAD protocol that can go ahead and say, here's your name, and it writes that to firmware, and after that, it's there. It will be picked up automatically. So at least I'm not sure what Mellanox has done in their hardware. Maybe they have something similar, but at least for Omnipath, that's how that's handled.
So, couple of questions, comments. So you mentioned you wanted to do the Ibacm ready earlier so that ULPs can use it. First comment is IP or IB doesn't use rdma-core, so current code. So do you have patches which converts it? I'm assuming that to leverage Ibacm, you need to use rdma-core. Is that accurate?
I'm sorry I wasn't clear on that. For kernel ULPs, the ULPs are querying the SA, where's my picture? They're querying the SA protocol, I don't know how to use this. They're querying the SA module here in the middle. So the ULP queries that as if it's an SA. And what that SA client code has been modified to do now is take that SA query and send it to user space if somebody's listening on the net link.
Right, right. I think I saw that part. So I think this clarifies, so that's fine.
Okay. So rdma-core is not?
No, I understand
okay.
that. So that's good. The second part is for the fabrics like, let's say, Rocky, which doesn't really need any path records and all. What really Ibacm offers apart from a neighbor cache, which is just ARP cache, for address resolution?
It doesn't offer even an ARP cache. It's really focused on SA data for InfiniBand and Omnipath.
Yeah. Okay.
Yeah.
Thanks
so
for that.
for Rocky networks, I don't think this applies. There's other ARP cache daemons that exist that could be used in a similar fashion for scaling iWarp or Rocky.
Right. Yeah. Thanks.
Yeah.